Okay. We have difficulty. It can be difficult to measure things like formants in a spectrum or a spectrogram. So, I just want to point out a couple of things that come up that have come up so far in the first lab assignment here, and ways you might be able to get around it uh, in the time that remains. I know that time is short, but anyway, here we go. So I'm going to start with uh, an example of the sound. Uh, so first of all, let's see. Here's an example of the word meat. Meat. This is one of the words from our from the word list that's given, and we notice in the spectrogram we have the M sound, the M, E, and then there's the closure and release of the T. Now, one thing that can be tempting to do here is to just get a spectrum of the whole thing. Do spectrum, fast Fourier transform. There's our spectrum. We can view this. Uh, uh, just select about the bottom 5,000 hertz. And I see some harmonics at the beginning. That gets overwhelmed by some noise here. There's some general bumps and stuff. The big problem with this spectrum is that it's not actually a spectrum of the vowel, it's a spectrum of the whole word. So remember that the Fourier transform takes a span of audio and it tries to identify which frequencies are present in that audio and what the amplitude of each one is. And if you span over more than just one sound, you're going to have a weird blending of information from multiple sounds. So this is definitely not what you want to do. If you're doing this, you're getting your spectrum from the whole word. You're not measuring the formants of the vowel. You're measuring something kind of slightly incoherent. So what you want to do, if we go in to that sound, I'm going to get in, here we go. So that meet, view and edit. What we want to do is select, here's the vowel. How do I know that's the vowel? Well, if I click along the bottom here, you see these different bars and one corresponds to the pink selection I've made. And I can hear the E. If I click before, I hear the and after, okay, so you can select different portions and test this out, but this is definitely the portion that I want. So now I want to just get the spectrum from that section, and here I go under spectrogram, view spectral slice, or control L in this case, and that gives me this spectrum, and this is a little bit cleaner. If I'm actually going to zoom down a little bit more just to help out. I have sort of three strong harmonics at the beginning, and then a big valley, and then another peak here, and then further peaks up there. So I would say F1 is somewhere in this range. F2 is definitely around here, about 2000, and F3 is up here at 3000. Okay, now there is a second issue that I want to discuss. So if we zoom into this lower portion, we've got three peaks here, 116, 231, 346 roughly. These are evenly spaced. These are clearly three harmonics properties of the fundamental frequency, but they're all quite high in a slight descending range. So the first formant is probably spanning those. So what do we take as the center frequency of that? Now, when you're using a narrowband spectrum like this, where you've got a wide selection, a longer portion, the whole vowel, and you're getting individual harmonic peaks, one convention is just to take the highest peak. And in this case, the highest peak is definitely that first one at 118. Now, that is much lower than we would expect for a first formant. And in fact, because we see all three of these harmonics quite high in amplitude, that it might make more sense to take the middle one of those as somewhere in the middle of that overall peak. So somewhere around 230, and that corresponds. Here's another thing that you can use. We have reference data. We have information about other studies that have measured formants in different ways. And so here is Appendix C from the textbook, the Reitz and Youngman phonetics textbook. and it reports values from a 1952 study by Peterson and Barney and a 1995 study by Hillenbrand, Getty, Clark, and Wheeler. And it reports values for various, these are American English vowels, for F1, F2, and F3 in children, adult women, and adult men for both studies. There's a lot of numbers here, but for example, the E, like in meat, their male value here is 267 for the Peterson and Barney and 343 hertz for the other study. So this can give you a sort of sanity check on whereabouts do you expect these. Of course, as scientists, we don't want our measurements to be guided by our expectations, but as we're learning how to do this and learning, what are the reasonable ways to measure this, this can be a little bit of a guidepost at least. Okay. Um, so another thing that comes up, I'm going to use a different sound here. We've got uh, bring that up. This is the word pancake. Pancake. And I just did this so that I could get a couple of clean vowels out of it. So for the ah vowel, here's a spectrum that I got for the ah, using, as I just described, using selecting that portion. See a really nice harmonic structure here. And what you often see, it's really common across when you have a clean recording and a relatively uh, relatively periodic voice. So you're not doing a lot of creak, you're not doing a lot of breathiness. What you'll see is the first harmonic has a lot of energy in it. Remember, there's a sort of sharp drop off, like what is it, 12 decibels per octave in the glottal source function. And an octave is a doubling. So the difference between the first and the second harmonic is actually an octave, right? Because that's a doubling of frequency. And so you get a 12 decibel drop off in the source, and often with the filter that's applied to that, the filter isn't so sharp that it puts the first harmonic below the second harmonic. And so what you'll often see in the spectrum is something like this, where the first harmonic is higher, and that's not because there's a formant there, but just because the first formant starts off so high. Uh, and if we want to use that reference that I was just talking about, the Hillenbrand, the various studies from the appendix here, for the a vowel, that's the fourth column here, the first formant for adult males is around the 600, this is 591, 664, so it's in that range, um, and even higher for adult females and for children. And so if we go to this spectrum, this next peak here, that 750, that's more in line with what we expect than that very first harmonic. It's only for the close vowels where you expect very low first formant that sometimes that first formant really does sort of climb down into the range of that first harmonic. So that's the other thing to look out for. Like you're generally looking for peaks, for harmonics that stick out higher than their neighbors, but that first harmonic is often high just inherently, and it has nothing to do with the formants, which is, remember, what what we're trying to measure here. Okay, so make sure that you're measuring just the vowel. Be careful of identifying that first harmonic with the formant. Um, Generally, if it's part of the format, it's sort of cooperating with the second and third harmonics. If you're doing broadband spectrum, so instead of taking the whole vowel, you're just taking a point in the middle and taking the narrow, the very, not narrow, the very short time window to get that spectrum, then you're going to get something different. So, for example, if we go to that in pancake, that's about here. If we stick our cursor in the middle, our spectrogram settings show us that we were looking at a window length of 5 milliseconds. So if I just take the spectral slice from a point rather than taking a span, it's actually going to select, it's going to build the spectrum on 5 milliseconds right around that cursor. And so what we see here, we don't see the harmonics. We do see a high peak right at the beginning, like it starts high, it's already falling. So that's that same effect of the first harmonic being so high. But then our first sort of actual peak is again in that 700 plus range. So this is one advantage of the broadband spectrum, is that you don't get that sort of distracting influence of one harmonic being high for some reason that's not to do with the form. If you take that narrow, that short time window, you get a broadband, right? Less frequency, less precision on the frequency domain. You get a broader spectrum, which can be a little bit easier. The downside is that because we can't see where the harmonics are, when we look along, does this and this count as separate peaks? Technically, there's a point here where the things on either side are lower. Similar here, a point where the things on either side are lower, but it's harder to say whether those are important or not, and then it gets up again. Whereas if I take the earlier spectrum that we were looking at, here's our first harmonic that we're going to disregard because it's just the first harmonic. We go down, there's nothing, these are clearly not, these do not seem to be strong peaks, but then here's a clear peak up here at the 750 area. This is coming down from that. So the actual resonance is probably somewhere in between, but on the narrowband spectrum, we take the harmonic peak. And then we have another peak here. So the second formant would probably be around 1120, and the third peak up here around 1700, right? So um, it is a bit of an aesthetic preference. Do you like having a lot of peaks, a lot of clean peaks, where you can sort of see the overall trends in the peaks, or do you want to blur across those and see the overall bumps and just try to deal with the jiggles as you go? So that's the distinction between the narrowband spectrum with the harmonics and the broadband spectrum that doesn't have the harmonics. And yeah, like I said, that's more of an aesthetic preference. I tend to prefer the narrowband spectrum when I'm doing the measurement, but that is entirely an aesthetic preference. I don't think it's strictly a matter of it's inherently more precise as a form of measurement or anything. So anyway, I hope those pointers give you some help if you're having difficulty with formant measures. Um, and the last thing is just to remind you to be consistent. So if you're going with the narrowband spectra, all of the measures that you're comparing within your group, within your assignment, should be taken using a narrowband spectrum. So select the whole vowel, take the spectrum from that and get that. If you're going with the broadband spectrum, you're taking a point and just taking that 5 millisecond window. All of your measures should be based on that because you're wanting to compare your measures to each other. Do I, within my vowels, do I see the patterns that we were talking about in class with respect to the first formant, second formant, third formant, and how that relates to articulation? Um, and you can only compare like with like. So you've got to compare similar measurement approaches. So that's I think the last thing I'll mention in this video. I hope that's helpful. Yeah, so happy measuring.